Hi everyone, welcome to goclasses. So in this session, we will study, we will understand redundancies in the DBMS, right? So we will study what redundancies are possible in different normal forms. Which normal form does not have redundancy? Okay. So basically, we will understand redundancies in this lecture. Now let me start. So this is the content of this lecture. In this lecture, we will study. First of all, we will understand the redundancy. What is a redundancy? Okay, then we will see why BCNF is free from FD causing redundancies. Okay, so basically, why BCNF that is free from FD functional dependencies caused redundancies, and is BCNF free from all the redundancy? That is our question that we will answer. Okay, so this is our content for this lecture, lecture number 15. Now we start. Okay, let's start now. Okay, so and you can join this Telegram group. Okay, if you are preparing for the gate exam, then for all your doubt discussions, you can join this Telegram group. This is the username gate_csc go classes. Okay, now let's understand redundancy. What are redundancies? Let's understand this first. So first of all, you tell me, can a trivial FD create redundancy? Can a trivial functional dependency, can it create redundancy? Can it create redundancy? No. Why? What is the reason? Why trivial functional dependency can never create redundancy? Because they are trivial, right? Okay, because they are always available, they are always present in all the relations. Okay, because yes or no, they are always present in all the relations. These are trivial, they will always be true. Trivial functional dependency means they are always true, they will always hold in every relation, they will always hold. Yes or no, they will always hold in all the relations. So these are trivial, they do not cause any redundancy. So who will cause the redundancy? So I can say that non-trivial FDs, they may create redundancy, right? Yes or no? So non-trivial functional dependency, they may create redundancy. Now let's see with example, let's try to understand this. So for example, consider this relation: student ID, student name, date of birth, state, district. Consider this relation you have. Okay. Now let me assume that this is a student table, right? Okay. So let's assume this is a student relation. This is a student relation. Okay. Now tell me, who implies whom, district or state? Like, can I say, if you know the district, can you tell me the state? Yes or no? If I tell you the district name, automatically you can tell me the state name. Okay, state name. So I can say that district, okay, it determines state. If I tell you the district name, for example, if I tell you Mumbai, then automatically you will tell me state is Maharashtra. Yes or no? So you can notice that district functionally determines state. Okay, so district determines state. So this FD we have, and this is the primary key, right? Yes or no? This is the primary key, that is student ID. This is student ID. This is the primary key. Now, in this, you can notice this is a, what can I say about this district? District determines state. This is a non-trivial FD, correct? Yes or no? This is not a trivial FD. This is a non-trivial functional dependency. Now, this is a non-trivial functional dependency. You tell me one thing. In this student relation, in this relation, if there are, let me assume that there are 20,000 students. Let me assume there are 20,000 students. Okay, let me assume there are 20,000, and out of these 20,000 students, let me assume that out of these, 1,000 are from, 1,000 students are from, let's assume they are from, okay, I can say they are from Jaipur. Let's assume. Okay, so 1,000 students are from Jaipur. Then can you notice what will happen? What will happen here? So if 1,000 students are from Jaipur, in this table, in the student relation, what will happen in the student relation? In the student relation, this is student ID. Okay, and some extra things are there. Some extra things are there, and there is district, and there is district. Okay, and there is state. Now you can notice that there are 1,000 students who are from Jaipur, correct? Who are from Jaipur. Okay, so there are 1,000 students who are from Jaipur. 1,000 students are from Jaipur. Okay, so what will happen? If 1,000 students are from Jaipur, then what will happen? The Rajasthan, this will repeat. This will repeat 1,000 times, correct? Yes or no? Agree or not? So if 1,000 students are from Jaipur, then this Rajasthan repeats. So here, what is redundancy? For example, this student is from Jaipur. 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 This student, okay, and so on, and so on. So these are the Jaipur students. You tell me, is this redundancy? Tell me, is this redundancy? Is this redundancy? Is this data redundancy? Tell me, is this data redundancy? Is this data redundant? Tell me, is this data redundant? This data is not redundant, right? This is the important information. This is the important information that S1 is from Jaipur, S2 is from Jaipur, S3 is from Jaipur, S4 is from Jaipur. This is the important information. This is not redundant. Yes or no? Agree or not? This information is not redundant. Okay, you are taking from every student, you are asking from where you are. What is your district? From every student, you are asking what is your district. So there is nothing redundant here. What is redundant? This is redundant that after asking for the district, okay, you don't have to ask for the state. Yes or no? After asking the district, you don't have to ask. This is redundant. See, this is redundancy. Yes or no? Can you notice? This is redundancy. Why this is redundancy? This is redundancy because if you know that district is Jaipur, then automatically it will come. Automatically this data is coming. Tell me, is this data coming automatically or is this data coming automatically? Which data is coming automatically? Is this data coming automatically or is this data coming automatically? So you cannot, the state data is coming automatically. So I can say this is redundant. Yes or no? So this is redundancy. Is this clear to everyone? So what is redundancy? So you can notice this is a non-trivial FD. Okay, this is a non-trivial FD. And in this because of this non-trivial FD, what is happening? We are getting redundancy. This data, okay, this data is redundant. You can notice, for example, 1,000 tuples. Okay, 1,000 tuples. This data will be redundant. Okay, and so on. So 1,000 tuples of district Jaipur. 1,000 tuples of district Jaipur. So this is the data. This is the redundancy. Remember, this is not redundancy. This is not redundant. Yes or no? Is this clear? So this is not redundant. This is the important information that you have to record. You have to record this information. So this is not redundant, but this is redundant. So here, what is the solution? Can anyone tell me, like, what could have been the solution to reduce this redundancy? To reduce this redundancy, what could have been a solution? So this could have been a solution that what you do, okay, you have to put the district. Yes or no? Of course, this could be a solution. You have to do this. So this is not redundant. Okay, so this is what you have to ask from the student. What you ask? You ask only district. From the student, you ask only district. Okay, so here that is fine. And you create another table. You create another table where you have district comma, state. You create another table where you have district comma state. Is this clear? So you can call it another table. Okay, for example, maybe you can call this table R. So you can create this. Now in this table, there is no redundancy. In this table, one time you write Jaipur, one time you write Rajasthan. Okay, one time you write Bangalore, one time you write Bangalore, one time you write Karnataka. Okay, yes or no? So you can notice that now there is no redundancy. Is this clear to everyone? Tell me. So from the student, you ask, what is your district? From the student, just directly ask, what is your district? But then what you do? From another table, you find out the state name. So now there is no redundancy. This is a solution, I can say. Correct or not? So I can say this is a solution. So this is a solution. So solution is what? That is decomposition. So what is a solution? What is a solution? Solution is basically decomposition. Correct? Solution is a decomposition. We are decomposing. Okay, so that is a solution. So solution is decomposition. But anyway, did you understand what is redundancy? This is what I want to teach you. Okay. Mavit is saying we are saving one column space. No, a lot of space we are saving. Mavit, a lot of space we are saving. 1,000 tuples of redundancy. This is 1,000 tuples of redundancy. And then you can notice there will be more redundancy because there are 20,000 students. Okay, so there will be a lot of redundancy. In this table, almost I can say almost all the tuples have redundancy. Correct? Almost all the tuples, they have redundancy. They have redundant data. Okay, so this is what I'm saying. And this is a solution. What is the solution? Solution is decomposition. You can decompose. And what you can do? So this table and this table, two tables you can create, two relation you can create. So this is the solution, decomposition. But did you understand what is redundancy? Our topic is what is our topic is understanding redundancy. Did you understand what is redundancy, what is not redundancy, what is useful data and what is redundant data? Did you understand that? Yes or no? What is useful data and what is redundant data? Like for example, consider this data. Okay, consider this table. Another example I'm taking. So you have three attributes A, B, C, and you have AB determining C, C determining B. Now, okay, now you tell me which of them will both are non-trivial, right? Yes or no? Can you notice both are non-trivial FD? This is a non-trivial FD. This is a non-trivial FD. This is a non-trivial FD, and this is also a non-trivial FD. Which of them will create a redundancy? Which of these FDs, which FD will create redundancy? This is my question. My question is which non-trivial FD? Both are non-trivial FD. Both are non-trivial. Both are non-trivial FD. Now my question is which non-trivial FD may create redundancy? May create redundancy in the data. May create redundancy in a database. In relation R. Okay, I can say in relation R, which of them can create redundancy? Okay, which of them may create redundancy? So the answer is only this can create. Only this can create. So I can say only this can create. Remember, C determining B. This can create redundancy. This will not create redundancy. Okay, let's check it out. Let's check it out. So you have a relation R in which you have three attributes A, B, C, and the question is saying that AB determines C and C determines B. Now, can you notice what is the candidate key? Can anyone tell me what is the candidate key? Or I can say what is the candidate key? So AB is a candidate key, AC is a candidate key. These are the candidate key. So can I call them super key also? Of course, they are super key also. Okay, so I can call them super key. They are super key. Now, can you notice because they are super key, they can never create redundancy. This AB determining C, this can never create a redundancy because it can see why redundancy is happening in this table. In this table, why the redundancy was happening? Can anyone tell me in this table why the redundancy was happening? Because repetition of this causes repetition of this. Agree or not? Agree or not? Repetition of Jaipur causes repetition of Rajasthan. Repetition of Bangalore causes repetition of Karnataka. Repetition of one column causes repetition of another column. And this is not a key, so it will repeat. So you can notice, okay, why redundancy? Why district determining state creating redundancy? So this you understand why this is creating redundancy. This you understand why this is creating redundancy. There are two reasons why this is creating redundancy. The first is because because you can notice repetition. The first reason is repetition of district causes repetition of state. Yes or no? Repetition of a district. Okay, for example, let's assume Bangalore. Okay, for example, let's assume Bengaluru. Okay, nowadays, so Bengaluru. Okay, so anyway, so you can notice that. So repetition of district that causes repetition of district causes repetition of state. Yes or no? So this is the idea. So you can notice repetition of district. If you repeat the district, that will cause the repetition of a state. For example, if you repeat Bengaluru, then Karnataka will repeat. Okay. So if you repeat this Bengaluru, then automatically Karnataka will repeat. And the second point, it is not a super key, so it will repeat. Yes or no? Second point, since district is not super key. Yes or no? Since district is not super key, in a student table, in the student table, so it will repeat. So it may repeat. Yes or no? So it may repeat. So it may repeat. Agree or not? Okay, so it may repeat. So these are the two reasons. So it may repeat. So these are the two reasons. You can notice. Okay, very simple. So why this is creating redundancy? Why this district determining state? Why this is creating redundancy? Because a repetition of district will automatically repeat the state. If you repeat Bengaluru 100 times, then Karnataka will repeat 100 times. Now you can notice, if you repeat Jaipur 1000 times, then Rajasthan will repeat 1000 times. Now you can, and the second reason is this. What is the second reason? And the second reason is this, that since district is not a super key, okay, so it may repeat. It may definitely repeat. Okay, so that is the reason you can notice, because this is not a super key, this district, this is not a super key, so it may repeat. So it will cause the repetition of state also. Okay, but you can notice in this example, consider this example. Okay, AB can never repeat. Yes or no? Can you notice? AB can never repeat. AB can never repeat. Okay, this will never, they can never be same. They can never be same. Never same. Okay, they can never be same. So you can notice this AB cannot repeat. This AB cannot repeat. So whatever data you put in the C, can I say, even if that cannot be redundant, right? For example, with 1, 2, let's assume you have 3. Okay, with 2, 3, can you have 3? Sorry, with 2, 2, can you have 3? Yeah. Is this redundancy? Okay, tell me. Is this redundancy? Array, this is not redundancy, because for a different data, this is 3. For this data, this is 3. For different data, you are getting 3, 3. For example, your name is Akash, my name is Akash. Okay, is that redundancy? Tell me. Your name is Akash, my name is Akash. Is that redundancy? That is not redundancy, right? Yes or no? Okay, so this is the point. That is what I'm saying. So you can notice different data. So they can never be same. You can notice they can never be same. These two tuples, they can never be same. So now, okay, so if I have, for example, let's assume I have 4, 4, and the data is 4. And let's assume I have 5, 4, and let's assume data is 4. Okay, so you can notice this is not redundancy. Agree or not? So here if you notice this is not redundancy. This is not a redundancy. This is not redundancy. Okay, so you can very easily see that this AB determining C, this cannot create redundancy. Agree? Okay, agree that this AB determining C, this FD okay, this FD does not create redundancy. Does not create redundancy. Agree or not? Why this does not create redundancy? Because LHS is super key. Because LHS is super key, correct? Because LHS is super key, so it cannot repeat. The LHS cannot repeat. LHS cannot repeat. So, okay, so easily you can notice there is no redundancy. Okay, because for a different data you are getting 3. For a different data you are getting 3. For a different data you are getting 4. For a different data you are getting 4. So this is not redundancy. Okay, so very simple. So you can notice because LHS is super key, so this FD cannot create redundancy. What about this FD? What about the second FD, that is C determining B? Consider this FD, A, B, C. Okay, now what you do? Now you consider this FD. Okay, so now what you do? Now you consider this FD where you already know AB determining C, C determining B. Now here you can notice that this is a non-trivial FD. This is a non-trivial FD. Correct? This is a non-trivial FD, and LHS is not a super key. You can notice LHS is not a super key. So if LHS is not super key, what will happen here? It will happen that if you repeat this 3, 3, 3, can I guarantee this? Okay, see, very simple. Okay, let's assume this is 2. Now. Okay, if I repeat this 3, automatically this data will repeat. Yes or no? Automatically this data will repeat. Agree or not? Automatically this data will repeat. So this is called redundancy. Okay, yes, this is called redundancy. This is called redundancy. And remember, can C repeat? Can C repeat? Can C repeat? Yes, because it is not a super key. Because C is not a super key, so it can repeat. So you can easily see that, okay, because of this FD, we can get redundancy. Because of this FD, we can get redundancy. Of course, it can be like 1, 2, 2, 3, 3, 4, 5. Okay, of course. Okay, but the point is very simple that, okay, so you, in this relation, you have AB determining C also, AB determining C also, C determining B also. But you can notice you are getting redundancy. So you are getting redundancy. So I can say this C determining B. Okay, look at this FD, C determining B. This FD causes redundancy. Correct? This FD causes redundancy. And what is the reason? What is the reason it is causing redundancy? Because LHS is not super key. Because LHS is not super key. Okay, so this is the understanding of redundancy. Did you understand redundancy? So can I say non-trivial FD may create redundancy, right? Agree? Okay, I can say non-trivial FD may create a redundancy. But okay, is it true for all type of non-trivial FD? Can I say all the non-trivial FD they will create which non-trivial FD can never create redundancy? Which FD? Which non-trivial FD can never create redundancy where LHS is super key? Yes or no? So non-trivial FD in which LHS is super key never creates, yes or no, where LHS is super key, that will never create a redundancy. Okay, so this is a simple point. If LHS is super key, so very simple point. This is a very simple point that if you have a FD, functional dependency, I am talking about functional dependency as determining something. Okay, now if this X is, if this LHS, if this LHS X is super key, then this FD cannot cause redundancy. This FD cannot create redundancy. See, this FD cannot create redundancy. Are you getting my point? This FD cannot create redundancy. Okay, this functional dependency cannot create redundancy. Okay, this functional dependency cannot create redundancy if X is a super key. Okay, very simple. So if LHS is super key, then definitely this functional dependency cannot create redundancy. And of course, trivial. So finally, okay, so finally, what is your conclusion? Who can create? And trivial FD cannot create redundancy. Trivial functional dependency cannot create redundancy. So who can create? So finally, I can say where LHS is not super key. Non-trivial FD, where LHS is not super key, where LHS is not super key, these people can create a redundancy. Okay, yes or no? These people can create a redundancy. So I can say that FDs that create redundancy. So who are those? So FDs which may cause redundancy. FDs which may cause redundancy. Okay, which type of FDs can cause redundancy? So this type of FD where X determines alpha, okay, where this is non-trivial, of course. Okay, this must be a non-trivial FD, and X is not super key. X not super key. Okay, so this type of FDs they may create redundancy. Is this clear? They may cause redundancy. So very simple. So now you tell me, can BCNF have redundancy? In BCNF, what happens? Look at BCNF. In BCNF, what happens? If you see any non-trivial FD, every non-trivial FD, okay, whatever non-trivial FD you take, so every non-trivial FD has LHS super key, has LHS as super key, correct? Has LHS as super key. So LHS is always super key. Okay, so I can say this BCNF is free from redundancy, or I say, okay, which two statements should I say? Can I say it is free from, redundancy caused by redundancy? Can I say it is free from redundancy, or can I say it is free from, okay, which statement can I say? Can I say it is free from redundancy, or can I say it is free from redundancy caused by FDs? Caused by FDs. So which statement should I say? Can I say it is free from redundancy? This I will tell you. Okay, this I will tell you now. We will explain this now. Okay, our main topic is this. Okay, so this statement is not correct. This statement is correct. Is this clear? So BCNF is free from redundancy caused by FDs. Redundancy caused by FDs. So in the BCNF, FDs cannot cause redundancy. Someone else can cause. Yes or no? Is this clear? In BCNF, FDs, functional dependency, they can never create a redundancy. Someone else can create. FDs can never create redundancy. Someone else can create. Who is that someone else? That we will study now. Okay. So in the BCNF, functional dependency can never cause a redundancy. FDs, they can never cause a redundancy. But in BCNF, redundancy can be there. Someone else can create a redundancy. Who is that someone else? That we will study now. Is this clear to everyone? So if someone asks you, BCNF is free from redundancy, is this true or false? BCNF is free from redundancy. Is that true or false? That is false. Yes or no? In the BCNF, you can have redundancy, but you can never have redundancy created by FDs. Because of functional dependency, you can never get redundancy in the BCNF. Okay, because of functional dependency, you can never get redundancy. So BCNF is free from 100% free from redundancies caused due to FDs. Okay, let's see this. Okay, but 3NF can have, right? 3NF can have redundancy due to FD. Agree or not? 3NF can have redundancy due to FD because in the 3NF, the LHS may not be super key. Agree or not? The LHS may not be super key. So 3NF may have redundancy due to FDs, but BCNF is 100% free from redundancy due to FDs. Okay, now let's see. Is BCNF free from all the redundancy? Is BCNF free from all the redundancy? Let's see example. Consider this example. Let's assume there are two tables. I am giving you two tables. One table is courses. Which student has taken which course? In the real life, is this many to many or one to many? Okay, can I say, is this many to many or one to many? Look at this courses table you look at. Okay, so I am giving you two tables. One is courses table, another is movies table. In the courses table, you have which student has taken which course. So can I say one student can take many courses? Agree or not? One student can take many courses and one course can be taken by many students. So this is a many to many or not? One student can take many courses. Okay. And one course can be taken by many students. One course can be taken by many students. So you can clearly see that this is many to many relationship. Similarly, movies. One student can like many movies and one movie can be liked by many students. Yes or no? One movie is favorite of many students and one student has many favorite movies. Okay, so both are many to many relationship. Agree? Is there any redundancy in this course table? In the course table, do you have any redundancy? In the course table, do you have any redundancy? Look at the course table. Okay, look at the course table. Look at the course table where you have SID and where you have CID. In the course table, do you have redundancy? Any type of redundancy? Do you have redundancy? I'm asking, do you have redundancy? Any type of redundancy? Do you have redundancy? In the course table, do you have redundancy? Any type of redundancy? Tell me, for example, let's assume this student S1 has taken 3 courses, C1, C2, C3. Will you call this redundancy? Will you call this information redundancy? S1, S1, S1. Will you call it a redundancy? Will you call it redundancy? No. This is a useful information, right? That S1 has taken C1, S1 has taken C2, S1 has taken C3. This is not automatic information. Agree or not? This is not a useless information. This is not a repetition. This is useful. This is not a repetition. This is useful. Similarly, this C3 can be taken by, maybe this C3 has been taken by S2 also, S3 also, S4 also. So you can notice this is also not redundancy. Agree? This repetition is not a redundancy. This is not a redundant data. This is a useful information. This is not a redundant data. And similarly, you can notice this is not a redundant data. Yes or no? Agree? Is this clear? So here also no redundancy. So in this table, we have no redundancy. In this table, we have no redundancy. In this table, there is no redundancy. Is this clear? In this table, we have no redundancy. There is no redundancy. You can never have, in this table, you can never have redundant data. So any redundancy here, the answer is no. Correct? The answer is no. There is no redundancy. Now what you do? If there is no redundancy, then there is no redundancy due to FD also, due to functional dependency. Because can you notice? Okay, can you notice in this table, what is functional dependency? What are non-trivial functional dependency? Do you have any non-trivial functional dependency? Do you have any non-trivial FD? Do you have any non-trivial functional dependency? Do you have that? Do you have any non-trivial functional dependency? The answer is no. Array, there is no non-trivial functional dependency. Can SID determine CD? Can SID determine CD? No, SID cannot determine CD. Look at this. So SID cannot determine CD, and CID cannot determine SID. CID cannot determine SID. You can look at this. You can look at this. So there is no non-trivial FD, right? Yes or no? We have no non-trivial FD in this. So remember, if there is no redundancy, okay, which statement is true? Like no redundancy, can I say implies no FD redundancy? No FD caused redundancy? Yes or no? If there is no redundancy, then automatically there is no FD caused redundancy. But this statement is not true, right? Okay, this statement is not true. That yes or no? If FDs are not creating redundancy, someone else can create. Okay, functional dependency is not creating redundancy, then someone else can create. Okay, now important thing, what you do? So you can notice one thing, that any redundancy here, the answer is no. These two tables I gave you. Okay, look at these two tables. Look at these two tables. This table, these two tables. Course table, movie table. These two tables. Okay, these are many to many relationship. Both are many to many relationship. Okay, here also many to many, here also many to many. Okay, now, is there any redundancy in these two tables? In this table, there is no redundancy. There is no redundancy. But what if we merge them? What if we merge them? Look, okay, look, what if we merge them? Now let's assume that, see, okay, very simple point I want to say. Let's assume you have a movie, you have a course table, right? This is your course table. Okay, in the course table you have SID and you have CID. Let's assume this SID S1, okay, has taken two courses, C1, C2. Okay, or maybe S1 has also taken C3. Okay, so far this is useful information, three tuples. Agree? Three tuples, and this is a useful information. There are three tuples. Okay, so I can say these are three useful tuples. There is no redundancy. These are three useful tuples. Okay, I can say three informative tuples. Correct? Okay, three informative tuples. Now, okay, what I do, I also give you movies table. I also give you movies table. In the movies table, you have SID and you have CI and you have movie. And your movie. Let's assume that this is student S1 has three favorite movies. Okay, this student S1, let's assume this has three favorite movies, three different favorite movies he has. Maybe, okay, Lord of the Rings. Okay, so maybe Hera Fairy. Okay, and Kantara, or maybe Tumbad. Okay, so let's assume. So these are his favorite movies. Now, okay, actually these are my favorite movies. So anyway, so let's see. Anyway, these are the movies. So you can take. Okay, now you can also put a Tumbad here. That is also a very nice movie. Anyway, so tell me here what will happen. So there is no redundancy here. There is no redundancy here. You have three tuples here, right? Here also you have three tuples, correct? So there are three tuples here. There are three tuples here. Okay, there is no redundancy here. There is no redundancy here. So I can say there is no redundancy here. There is no redundancy here, and there is no redundancy here, right? Okay, we have no redundancy and we have no redundancy. Okay, so very simple. There is no redundancy, there is no redundancy. Now you tell me, if you merge them, and remember there is no FD here, right? Correct? There is no non-trivial FD here. There is no non-trivial FD here. There is no non-trivial FD here. Okay, now what if you merge them? Then what will happen? If you merge these two tables and you create the student table, a student table, which is a course table plus a movie table. So if you merge them, basically you are merging them, then what will happen? Then you will create a student table. In the student table, there will be three items. There will be SID, there will be CID, and there will be movie. And there will be movie. Okay, so there will be SID, CID, movie. How many tuples will be there? Can anyone tell me? How many tuples will be there? If you merge them, I'm merging them. Okay, no, not union. Can you take union? These two tables you have, can you take their union? Are they union compatible? Are they union compatible? Are they union compatible? They are not union compatible. They are not union compatible. Okay, if you merge them means joining them. Basically, you are joining them. Okay, you are joining them. So what if you join them? What if you join them? Okay, what if I join them? Two different tables you have, and what if you join them? So then what will happen? Then there will be, okay, so natural join, yes or no? You are doing the natural join. So now how many tuples will be there? Now how many tuples will be there if you do the natural join? There will be 9 tuples. There will be 9 tuples. Okay, redundant information you will get. Why? Tell me. See, very simple, very simple. Okay, very simple thing, very simple thing. You understand this, and that's it. So S1 course is C1. Now, because of this C1 course, unnecessarily, see, okay, unnecessarily because of this course, there are C1 course, C2 course, C3 course, right? So far, this is correct. There is no problem. But what will happen? Unnecessarily, this M1 will repeat 3 times. This movie M1 will repeat 3 times. Yes or no? This movie M1 will repeat 3 times. This movie M2, this movie M3. Okay. So this is what I'm saying. Can you notice that? This is fine. This is fine. These 3 tuples are fine. But unnecessarily, this is repeating. Yes or no? Agree or not? Unnecessarily, this is repeating. Similarly, what will happen? Similarly, S1, S1. He likes M2 movie. Yes or no? He likes M2 movie. He likes M2 movie. Because of this M2 movie, unnecessarily, again, this information will repeat. See, this information will again repeat. Agree or not? Are you getting my point? Please tell me. Are you getting this point? You are repeating unnecessarily the information. Now, because of M3 movie, what will happen? Because of M3 movie, what will happen? M3. Because of M3 movie, again, the courses will repeat. Again, the courses will repeat. Okay. So, can you notice why? Okay, what is happening? Is there any connection of movie comma course? Do they have any connection? Is there any connection of movie comma course? They have no connection, right? This movie does not care about any course. This course does not care about any movie. They have no connection. But still, what is happening? Because of this M1, unnecessarily this is coming 3 times. Because of M2 also, this is coming 3 times. Because of M3 also, this is coming 3 times. Or you can say that because of C1, this M1 is coming. See, because of C1, these movies are coming 3 times. Because of C2, these movies are coming 3 times. Similarly, because of C3, these movies are coming 3 times. So can you notice there is redundancy? Yes or no? Now you got redundancy. A lot of redundancy you got. Agree or not? Redundancy, a lot. Agree or not? So for example, if you have like, just think about it. If you have 100 tuples here, 100 tuples here for S1. S1 has taken 100 courses and S1 likes 200 movies. S1 has taken 100 courses. S1 likes 200 movies. Then can you notice there will be a lot of repetition, a lot of redundancy here. Is this clear? Can you visualize this? That a lot of redundancy you will get. Yes or no? So if you join them, okay, as long as they are separate, there is no redundancy. In the course table, no redundancy. In the movie table, there is no redundancy. But when you join them, these two tables, when you join them, then you are getting a lot of redundancy you are getting. Okay. Because of this movie M1, unnecessarily these courses are coming 3 times. For M2 also, these are coming 3 times. So, okay, like this. So did you understand there is redundancy? Did you understand that there is redundancy? Is this clear? In the table, there is redundancy. But in the student table, is there any FD? Is there any non-trivial FD? In this, do you have any non-trivial FD? Can anyone determine anyone? Okay, in the student table, can SID determine CID? You tell me this point, simple point I'm asking. Can SID determine CID? Can SID determine CID? Of course not. SID cannot determine CID. CID cannot determine SID. SID, CID together, can they imply movie? SID, CID together. SID, CID together, can they imply movie? They cannot imply movie. So, okay, they cannot imply movie, agree or not? So they also cannot imply movie. So basically you can you notice in this table, there is no non-trivial FD. Is this clear? There is no non-trivial FD. We don't have any non-trivial FD. There is no non-trivial FD. Still redundancy. Still in this table, there is redundancy. Still in this table, there is redundancy. So who created that redundancy? Arey, just think about it. कोई नॉन ट्रिवियल एफडी है ही नहीं. There is no non-trivial FD. There is no non-trivial FD. So definitely FD did not create this redundancy. Right? Yes or no? This redundancy definitely FD did not create. Agree? This FD did not create this redundancy. So who created this redundancy? Is this point clear? We will see who created, but is this point clear? 2 points are they clear? That very simple points. 2 points I am telling. I gave you 2 relations. One relation was courses relation, many to many relation, student course. A student can take many course. A course can be taken by many students. So I gave you one many to many relations, many to many table. Another many to many table I gave you. One student can like many movies. One movie can be liked by many students. So 2 different tables I gave you. This table, 2 different tables I gave you. This was many to many table. This was many to many table. So these 2 different tables I gave you. Was there any redundancy in these 2 tables? Was there any redundancy here? Was there any redundancy here? There was no redundancy, right? There was no redundancy in these 2 tables. But if you join them, if you do the natural join, then you will create a third table. Okay, in the third table, there will be 3 attributes. Now there is redundancy, yes or no? In that third table, when you join them, then you are getting a lot of redundancy you are getting. Because of every movie, courses are repeating, yes or no? Courses and movies, they don't care about each other. Course comma movie, they don't care about each other. But still, because of every movie, all the courses are repeating. Because of every movie, all the courses are repeating. Because of every course, all the movie are repeating. Because of every course, all the movie are repeating. So you can notice that when you join these 2 tables, then you are getting a lot of redundancy. But there is no non-trivial FD. In the if you join the table, there is no non-trivial FD. So FD did not create this. Yes or no? FD, what FD will say? FD will say, मैंने नहीं किया. Yes or no? This redundancy I did not create. But there is a redundancy. Are you getting my point? There is no non-trivial FD. So FD did not create the redundancy. Okay. But there is redundancy. So who created this redundancy? Yes or no? Who created this redundancy? So that is what we need to see. So is this clear? So you can notice, is there any redundancy? The answer is yes. A lot of redundancy you have. Okay, a lot of redundancy you have. So who created this? Any non-trivial FD? Do you have any non-trivial FD? There is no non-trivial FD. So what you can see? See this. See. So who was causing this redundancy? FD did not create this redundancy. So who caused this redundancy? Okay, before. So who was causing this redundancy? Yes or no? Who is causing this? FD is not creating redundancy. So who is creating this redundancy? Yes or no? So that is what we need to see. So before that, you ask yourself, why this redundancy came? Yes or no? Before seeing who created, yes or no? Before seeing who created, you ask yourself why this redundancy came. This redundancy came, but why? Are you getting my point? There is no non-trivial FD, but still you got the redundancy. Why this redundancy came? And the reason is very simple. What was the reason? The reason is very simple, that too many to many, more than one many to many relationship you are putting in a single table. What we did? Yes or no? What we did? More than one many to many relationship, more than one many to many relationship, you are putting in a single table. More than one many to many relationship, you have many to many relationship. Okay, there is many to many relationship here, there is many to many relationship here. So more than one many to many relationship you are putting in a single table. Then who 2 people are fighting? Who 2 people are fighting? Now these 2 people are fighting. They have nothing to do with each other. They have nothing to do with each other. Okay, this is a many to many relationship. This is a many to many relationship. But when you put them in a single table, then these 2 people are fighting. Because of every movie, all the courses are repeating. Because of every course, all the movies are repeating. Is this point clear to everyone? Please tell me. So this is the reason, because you are putting more than one many to many relationship in a single table. Is this clear? Let me know. Is this crystal clear? See, a simple analogy I can give you. A simple analogy I can give you. Like, for example, okay, let's assume there is a, have you seen the Govinda movie? Have you seen the Govinda movie? So in the Govinda movie, there is a, most of the time he has 2 wives. Okay, most of the time he has two wives. Okay, most of the time. Okay, like typical Govinda movie will have at least two wives. Okay, definitely. Okay, at least two, maybe three, maybe four, I don't know. Okay, but so without two wives, Govinda does not make any movie. So you can notice that in this movie, okay, what happens initially? This will happen. Okay, Govinda is very happy with Silpa Shetty here. Okay, okay, Govinda, first wife, wife one. Okay, they are very happy. Okay, and in the another song, he is very happy with wife two. But after some time, what will happen? After some time, what will happen? The problem will happen. Okay, the problem will happen. And now actually the problem is happening between these two. Now the problem is happening between these two. Okay, so anyway, is this clear? So same seems something. This is just an analogy. Of course, this is just an analogy. Actually, something is happening here. There is many to many relationship here. There is many to many relationship here. Now you can notice when they are separate, there is no problem, right? Yes or no? Like for example, when they are separate, like you have SID. Okay, this is your Govinda. So Govinda with courses. Okay, there is no problem as long as they are separate. As long as they are separate. Okay, movie is very good. Movie is humorous. Okay, so you will laugh. But what will happen? But what is happening here? So you can notice. So as long as they are in the separate table, there is no redundancy. You have no redundancy. Okay, so I can say plus movies. So you can notice that there is many to many relationship. Okay, there is many to many relationship. Here also many to many relationship, and here also many to many relationship. Is this clear? So here also many to many relationship, and here also many to many relationship. So similarly, here also many to many relationship. A student can like many movies, and a movie can be liked by many students. Okay, so you can notice these are many to many. But the problem will happen when you put more than one many to many relationship in a single table. Is this clear? Tell me, is this clear? So when you put them in the single table, now the problem is happening. Many to many, more than one many to many relationship. When you join them, in a single table, when you put them in a single table, then there will be problem. Okay, there will be problem between these two. There will be problem between these two. What will happen? For every movie, all the courses will repeat. Okay, because of movie one, all the courses will repeat. Because of course one, all the movies will repeat. So because of every movie, all the courses will repeat. Because of every course, all the movies will repeat. Actually, they don't care about each other. Okay, if they are separate, course and movies, if they are separate in the separate table, they don't care about each other. They don't create any problem. They don't create any problem. But if you join them in a single table, then they are creating problem. Is this point clear? Let me know. Let me know. So this is why you are getting the redundancy. So you are getting redundancy. There is no non-trivial FD. Still you are getting redundancy. Okay, why you are getting redundancy? Because you are putting more than one many-to-many relationship in a single table. And when you do this, then a new type of redundancy, then a new type of dependency is created. See, when you do this, what you do? See. When you do this, when you do this, when you put more than one many-to-many relationship, more than one many-to-many relationship, if you put in a single table, then a new type of dependency is created. Then a new type of dependency is created that is called multi-valued dependency. Okay, so when you do this, remember when you do this, when you put more than one many-to-many relationship, more than one many-to-many relationship, this and this, when you put them in the single table, then a new type of dependency is created here. A new type of dependency is created here between these two. Between these two, a new type of dependency is created here. Yes or no? Can I say this? A new type of dependency is created here. A new type of dependency is created between these two. Because what will happen? Because of every movie, all the courses will repeat. Because of every course, all the movie will repeat. Yes or no? Agree or not? Is this clear to everyone? Please tell me. So a new type of dependency is created. What is this new type of dependency? What is this new type of dependency? So tell me, like what is this new type of dependency is created? This new type of dependency is basically saying that because of every movie, all courses will repeat. Because of every course, all the movies will repeat. Are you getting my point? A new type of dependency is created. A new type of dependency is created. Every movie causes repetition of every course. Every movie causes repetition of all course, repetition of all courses, and vice versa. Yes or no? Every movie causes repetition of all courses. So you can notice that very simple point. So every movie causes repetition of all courses, okay, and vice versa. And vice versa means every course will also cause repetition of all movies. Every course will cause repetition of all movies. So a new type of dependency has been created. Yes or no? Can you notice? And this is a new type of dependency. This is a new type of dependency. They don't care about each other. Array, see, in the FD, they care about each other, right? In the functional dependency, they care about each other. Like district determines state. Do they care about each other? District, state. If you tell anyone, okay, in the world, go to anyone and tell district, state, automatically they will tell you there is some connection. Yes or no? Automatically they will tell you, agree or not? Are you getting my point? The functional dependency has a natural connection. Okay, if you tell anyone that district, state, so they will tell you there is some connection. Natural connection is there. Functional dependency is basically a natural connection. But if you tell anyone movies and courses, what they will say? Tell me what they will say. They will say there is no connection, right? There is no dependency, right? So if you tell anyone movies, courses, there is no dependency. There is no dependency. But still, when you put them together, a new type of dependency is created. Because of every movie, all courses are repeating. Because of every course, all movies are repeating. So even though there is no natural connection, movies, courses, there is no natural connection, but still, when you put them together in a single table, then what is happening? A new type of dependency has been created. Now every movie is uh, causing the repetition of every course, and every course is causing the repetition of every movie. So a new dependency has been created. This is not a functional dependency, right? This new dependency that has been created, this new dependency that has been created, this is not a functional dependency, right? Yes or no? This is a new type of dependency which is called multi-valued dependency. Please tell me, is this crystal clear? Anyone has any doubt? Is this explanation, whatever I told you, is this crystal clear? Do you have any doubt? Please tell me. Please tell me, did you get it? Let me know. Is this crystal clear? Whatever we have seen. So naturally, there is no connection. Courses, movies, there is no connection. Naturally, if you ask anyone, there is no connection. They will say there is no connection between these two. Okay. But still, what is happening? When you merge them in a single table, when you put them in a single table, then okay, some dependency is created. Some new type of dependency is created. This new type of dependency is not functional dependency. Functional dependency is very natural thing. Okay. Functional dependency is a very natural scenario. Okay. But this new dependency is not natural. This new dependency is called multi-valued dependency. Okay. So this new type of dependency, okay, this new type of dependency has been created, and this new type of dependency is called, this is called multi-valued dependency. Okay, this is the explanation. Okay, I hope you understood everything. And let me tell you that, so you can notice this is the idea. So when we put more than one many-to-many relationship in a single table, you have more than one many-to-many relationship. When you put them in a single table, this type of situation gives birth to a new type of dependency, which is called MVD, multi-valued dependency. More than this, we don't require for the GATE exam. Whatever we have seen so far, that is enough. This MVD, 4NF, these things are not required for the GATE exam. So what we have seen, that is enough. More than this is not required. But now you can explain, right? Yes or no? If anyone asks you what is MVD, you can explain, right? Correct? Can you explain? Very natural explanation, like a very logical explanation you can give in any interview, whatever interview. Okay, if the interviewer will ask you, okay, tell me what are FD, what is MVD, a very logical explanation you can give. Yes or no? A very logical explanation you can give to the interview that this is MVD, this is FD. More than this is not required for the GATE exam. Whatever we have seen today, that is enough. In this lecture, whatever we have seen, that is more than enough for the GATE exam. Okay, so understood? Tell me, understood, right? Yes or no? Correct? Crystal clear? Okay. So that's it. So this is your topic. So you can notice, can I say BCNF? The previous table was in BCNF. Is this in BCNF? The student table, where you have SID, where you have CID, and where you have movie. Okay, can I say this is in BCNF? Why this is in BCNF? Can anyone give me the reason? Anyone, give me the reason why this is in BCNF? Because there is no non-trivial FD, right? Array, there is no non-trivial FD, so there is no violation. Because there is no non-trivial functional dependency, though. Okay, so there is no violation of BCNF. So we have no violation of BCNF because there is no non-trivial FD. So there is no violation. You cannot violate the BCNF. Okay, so I can say this table was in BCNF. So this table is in BCNF. Still, this table has redundancy. Okay, so BCNF may have redundancy. This is the final point. Is this clear? So you can notice, are there redundancies that are not okay? So you can notice BCNF is free from all redundancy. The answer is no. BCNF is free from redundancies caused by. The answer is yes. Okay, and are there redundancy which are not created by FD? Are there redundancy which are not created by FD? The answer is yes. There are redundancy. So redundancy can be created by two people. Now, can you notice? Redundancy can be created by two people. This redundancy can be created by functional dependencies. Okay, so this redundancy can be created by two people. Either it can be created by functional dependencies or it can be created by multi-valued dependencies. Okay. Now, is this clear? Okay, now, so is this clear to everyone? Now, by FDs, okay, these can be removed by this redundancy by FDs. Yes or no? So this redundancy by FDs, this can be removed by whom? Redundancy by FD. This can be removed by, if you want to remove it completely, removed completely by BCNF. Okay, so BCNF will completely remove it. So this is removed completely by BCNF. BCNF will completely remove it. And this redundancy by MVD, this will be removed by 4NF. This redundancy by MVD, this is removed by 4NF. Okay, this is completely removed by 4NF. Is this clear? This is completely removed by 4NF. Every FD is also MVD. Every FD is also MVD, Nikhil. But that we will not go into the details of that. Is this clear? We will not study the details of that. What we can do, if you want, then maybe in the practice course, maybe we can take some questions. Okay, maybe I can give you the definition in the practice course. Okay, but it is not required. Let me tell you, not at all required. Okay, this 4NF, MVD, multi-value dependency, these things are not at all required for the GATE exam. Okay, not even 0.0001%. This is not required. So my suggestion is skip this. Okay, this is my suggestion. Okay, but still, if you want that, okay, sir, just give us the definition. By chance some question comes, okay, just give us the definition of MVD. Okay, then maybe in the practice course we will see, but that is not our priority. Okay, this MVD 4NF, this is not our priority. Okay, we will, if we have time at the end, okay, then maybe we will see. But anyway, you can skip this. Is this clear? So whatever we have seen, that is enough. You understood this, right? See, without like whatever we did not see, forget about that. Whatever we have seen, did you understand it completely? Whatever I told you in this lecture, whatever we have seen, every concept that we have seen, every logic that we have seen, did you understand that logic completely in a crystal clear manner? And can you explain this to someone? Like if someone asks you, can you explain it to someone in a very crystal clear words? Okay, so that is enough. Now let's move on. So you can notice, are there redundancy that are not caused by FDs? And the answer is yes. A new form of redundancy, a new form of dependency. Is it possible to have redundancy without any non-trivial FD? Yes, it is possible. Okay, so another example you can take this, but I leave this question to you. For example, another example is this, like CID and instructor. Okay, this is many to many relationship. one course can have many instructors, right? Yes or no? One course can be taught by many instructors. Like when you go to IIT Bombay, ISC, IIT Delhi, okay, when you go to top colleges, then what will happen? Same course will be taken by 2 or 3 professors. Okay, the first half will be taken by some professor, the second half will be taken by some professor. So same course will be taken by multiple professors. Okay, it is also possible that 3 professors. Okay, it is also possible. So multiple professors will take the same course. Okay, for example, let's assume you take the DBMS course in the ISC or IIT Bombay. Okay, then what you can do? The first half will be taught by someone, some other professor, and the remaining half will be taught by some other professor. So basically, like combinedly, professors, they will take the course. Okay. So anyway, here you can notice what happens that so one course can be taken by many instructors, and one instructor can take many courses. So this is a many-to-many relationship. Similarly, this is also many-to-many relationship. Okay. Similarly, you can note this is also many-to-many relationship. One course can have many books, and one book can be used in many courses. So these are many-to-many relationship. Okay. Any redundancy here? The answer is no. There is no redundancy here. But if you merge them, okay, what if you merge them? Then redundancy will be created. Okay, then a redundancy will be created. If you merge them, then redundancy will be created. Okay, you can check it out. So if you merge them, then what will happen? If you merge them, then what will happen? It will happen that because of every instructor, okay, the books will repeat. Yes or no? Because of every instructor, for example, because of every instructor, all the books will repeat. Are you getting my point? Because of every instructor, all the books will repeat. B1, B2, B3, all the books will repeat. Similarly, because of one book, all the instructors will repeat. Because of one book, all the instructors will repeat. Okay, like I2, I3. So this is the, I can say this is a redundancy. Again, you got the redundancy. Okay, here you can notice again you got the redundancy. Okay, so a lot of redundancy. So you got a redundancy. Okay, this is another example, the same example we have already seen. So you can notice, okay, why we got this redundancy? The reason is very simple. Tell me, can anyone tell me why we got this redundancy? Why we got this redundancy? Because we are putting more than one many-to-many tables in the many-to-many relationship in the same table. Yes or no? Because we are putting more than one many-to-many relationship in the single table. Okay, more than one many-to-many relationship in the single table. Okay, so that is enough. So MVD for NF, multi-value dependency for NF, these things are not required for the GATE exam. Okay, so whatever we have seen, that is enough. That is more than enough. That's it. This is your chapter. Can you answer this question? Can you answer this question? Tell me the answer for this. Can you answer this question? Once you go to IIT, ISC, the understanding every course is not the purpose. Okay, it's not like you have to understand everything. Like for the GATE preparation, you have to understand every concept. Okay, you will focus on every concept, every question. You will solve many questions. You will do a lot of practice for the GATE exam preparation. But once you go to IIT, ISC, there basically the scenario is very different. Okay, so the scenario is very extremely different. Okay, so anyway, so let's see this. Let's see this question. So this is a GATE CSE 2002 question, and the question is saying that relation R with an associated set of functional dependency F is decomposed into BCNF. You are decomposing into BCNF. Okay, so you decompose into BCNF. The redundancy arising out of FDs. The question is asking the redundancies due to FDs. That will be 0, right? Yes or no? The redundancy due to FDs, that will be 0. The redundancy due to FDs, that will be 0. There is no redundancy in the BCNF. Nikhil, there is no redundancy in the BCNF. In the BCNF, there is no redundancy due to FD. Due to FD, because of functional dependencies, there is no redundancy in the BCNF. So the redundancy will be 0. Okay. Yeah, this is F closure. Okay, this is closure of F. F plus means F closure. Okay, so more than 0, no, this is not more than 0. More than 3 enough? No. Of course, less than 3 enough? Yes, of course, less than 3 enough. Basically, it will be 0. There is 0 there is zero redundancy because of FDs. Because of functional dependencies, there is zero redundancy. Okay, so this is your table. Sorry, this is your chapter. Now the chapter is over. Because of MVD, what will happen? If the same question is asking about the FD, if the same question asks you about redundancy, let's assume if the same question asks you about redundancy, if the same question asks you only about redundancy, then what will happen? Okay, so now it will be more than zero. It will be more than zero. Okay, but less than 3NF. It will be more than zero, but less than 3NF. Is this clear? Tell me. Okay, so the because of FD, there will be no redundancy. Because of FD, there will be no redundancy. So definitely less than 3NF. Definitely less than 3NF, right? Yes or no? Because 3NF can also have this 3NF can also have FD. This 3NF can also have redundancy caused by FDs. Redundancy caused by FDs. Okay, so definitely less than this, but more than zero. Okay, so that will be your answer. What is F plus? F plus is closure of FD. We already know what is F plus. F plus is closure of F. Closure of F. Set of functional dependency. Have we seen this concept? Nikhil, you have set of functional dependency. Can you find the closure of F? Can you find F plus? Nikhil, F plus. You have set of functional dependencies. F is set of functional dependencies. We have already seen how to find closure of F. If you have set of functional dependency, you have set of functional dependencies F. You can find the closure also. You can find the closure also. You can find the minimal cover also. You can find the closure also. You can find the minimal cover of F also. So both we have already seen. This we have seen. This we have seen. For this, we have also done the questions of Ullmann. Yes or no? Do you remember? We have done the Ullmann questions. Anyone remembers it? We have done Ullmann questions. Okay. So anyway, now let's take a small break. After the break, we will start the next session. Okay. MVD is not FD. FD is MVD. MVD may not be FD. Mavit, every FD is MVD, but MVD may not be FD. Okay, it's like MVD is superset of FD. MVD, that is superset of FD. That covers FD. MVD will cover FD. But anyway, don't worry about it. Okay, so let's take a, after the break, we will see 3NF and BCNF decomposition. After our class, compiler class will start. Okay, so in the next session, we will finish this 3NF, BCNF decomposition. Okay, so let's start in 5 minutes. Is that clear? In 5 minutes, we will start. Okay, thank you, everyone.